Hello, this is Mrs. Wong here. This video continues from the previous video. Okay, so we were looking at practice now 7 on page 13, question 1, part 2. Okay, so we're trying to find the value of k such that 15 times 135 times k gives us a perfect cube. Okay, so we recall that to get a perfect cube, we actually want the powers. Okay, the powers here to be multiples of 3. Okay, for perfect squares, we want the powers to be multiples of 2. Okay, so I have to now make sure that k contains some 3's and some 5's so that it will help make 3 to the power of 4 become 3 to the power of 6. Okay, I have to go to 3 to the power of 6. I cannot go down to 3 to the power of 3 because I have to multiply it. Okay, so I can only make the power bigger. And 5 to the power of 2 will then have to go up to 5 cube, okay, so that I can make it into a perfect cube. Okay, so I need a 3 square in k. I need 2 more, okay, and for the 5, I only need 1. Okay, so the question wants the smallest value of k. Okay, so this would be 45. Now, if they didn't say that it's the smallest, okay, no limit to k, then actually I can multiply by even more 3's, more 5's. Okay, I can even multiply by 7 cube. I can multiply by 11 cube. Okay, so that, well, as long as the powers are all multiples of 3, it's fine. Okay, but in this case, they want the smallest value, so we will keep k as small as possible. Okay. Now let's go on to part 3. Okay, so for part 3, they say that P and Q are both prime numbers. They want us to find the values of P and Q so that 15 times 135 times P over Q is a perfect cube. Okay, so if I write it out, it will be something like this. Okay, so if I multiply by a fraction, okay, 15 is 15 over 1, 135 is 135 over 1, so I can actually combine, okay, 3 to the power of 4 times 5 squared times P over Q. Okay, so now I want to make this a perfect cube. Okay, so now instead of just multiplying, okay, which is quite similar. Okay, so the numerators are quite similar. Okay, I also have a q below, okay, where I can divide. Okay, so when you divide, I actually bring down the powers. Okay, so if I were to take 3 to the power of 4 divided by 3. Okay, so 3 to the power of 4 is 4 times of 3 times 3 times 3 times 3, alright. Then I divide by 3, I'm actually left with 3 to the power cube. Okay, so when I multiply, it increases the power. When I divide, it decreases the power. So they tell us that P and Q are prime numbers. Okay, so we actually need to see which one do we need to increase the power, which one we need to decrease the power. Okay, so since P and Q are prime numbers, we are not expecting to make very big changes. So if we look at this, I can actually let P be 5 so that 5 squared times P becomes 5 cube because I want a perfect cube. Okay, then I can let Q be a 3 so that 3 to the power of 4 divided by 3 will give me 3 cube. Okay, so ultimately I will get 3 cube times 5 cube, which is a perfect cube. Okay, now I'm not going to make P and Q bigger to try and fit the cubes in. So the easiest possible way is to do this. Okay, so this is for question 1. We will now go on to question 2, part 1. Okay, they want to express 2016 as a product of its prime factors. This should be quite doable for you now. Okay, so take some time, pause the video, try 2 part 1, and then take a look at 2 part 2 and give it a try first. Okay, it's similar to question 1, part 2 and 3. Okay, so give it a try to see whether you can find a value of m and n before you continue watching the video to check your answer. Okay, so check your answer for 2 part 1. you have 2 to the power of 5 times 3 squared times 7. Okay, so for part 2, they want us to use 2016 over m equals to n square. Okay, n, they say that m and n are integers. Okay, integers are whole numbers, and n is as large as possible. Okay, n is as large as possible. So I'm going to look at this, So if n is as large as possible, n square is as large as possible. Yeah, but why do they write as n square? Okay, they are just trying to say that n square, this whole thing is a perfect square. Okay, and they want n to be as large as possible. Okay, and then m is an integer, it's a whole number. Okay, so if I take this value and I divide by m, and I want n squared to be as large as possible. Okay, it means that if this is large, I want it as large as possible, my m has to be as small as possible. Okay, I take one number, divide by a number as small as possible, then I can get a number that is as large as possible. Okay, so I want m to be small and n to be large, but n square has to be a perfect square. Okay, so you have to understand the concept of perfect square. Okay, so very similar to question 1, but they phrase it a little bit differently, so that it's slightly more challenging in this case. Okay, so what can m and n square be? Okay, so n square, if I'm looking at n square as a whole, I want it to be a perfect square. Okay, so if I look at this, 2 to the power of 5 is not a perfect square. And I'm going to divide it by m to make it into become a perfect square. When I divide, I reduce the power. So 2 to the power of 4, okay, 2 to the power of 5, sorry, 2 to the power of 5, okay, if I want to reduce it to n square, I'm going to reduce it to 2 to the power of 4, because I want n square to be as large as possible. So my m will need to have a 2 that I divide. Okay, then 3 square is already a perfect square, so I'm not going to change it. Okay, 7 is not a perfect square, so I have to divide it by 7. So if I look at this, my m is actually 14, and my n square is 2 to the power of 4 times 3 square. Now this is n square. They want you to find the value of n. Okay, so I'm going to take square root on both sides. Okay, if I take square root on both sides, I will get n is equals to, now 2, the power of 4, I divide by 2, so I will get a 2. For 3, the power 2 is divided by 2, and I get a 1. So I'm not going to write the 1 out. Okay, so I'm going to write like this. So n is 4 times 3, which is 12. Okay, so for this question, I will have m equals to 14, n equals to 12. Okay, let's look at part 3. Part 3 wants us to find the smallest whole number h, such that 2016 over h is a cube number. Okay, now a cube number is just a different way of saying I want a perfect cube. Okay, so I want 2016 over h to be a perfect cube. Now this is similar to what we've done in question 1 as well. So pause this video, take some time to try. Okay, so you should have tried this. Okay, so I want it to be a perfect cube. Okay, so my h, now I'm dividing, so I'm bringing the powers down. Okay, so I'm trying to bring 5 to a 2 cube. So my h will need a 2 square. I need to get rid of 2 of the 2's. Okay, then 3 square, well, it's not going to become a perfect cube unless I divide it by 3 square. So 3 square divided by 3 square is 1. Okay, 1 is a perfect cube. Then the 7 also has to be removed. Okay, so that I will get a perfect cube. So my h is actually 252. Okay, so that after dividing by h, I will actually get okay, so this one we do not write it out, but you can write it out to check. So if I divide this by h, I will get 2 cube only. Okay, the 3 square and 7, they have become 1. Okay, so it's just this, so it's a perfect cube. Okay, so this is it for practice now 7. We will go on to the next question. Okay, now for the next question, you are asked to calculate the value of square root 121 minus square root 36 plus cube root of 1000. Okay, now for this question, it is possible not to use your calculator to get the values if you are very well acquainted with your square roots, your cube roots, or your perfect squares and your perfect cubes. Okay, now for the question, as long as it doesn't say that you cannot use your calculator, you can actually make use of your calculator as well. Okay, so this is actually just to check whether you know where the square root, okay, and the cube roots are. Okay, so if you look at your calculator, okay, on the top part, okay, there is a x square. Okay, so the x square is for your square. The x cube is for the cube. Okay, now near those buttons, there's actually a square root. Okay, and then you see a box. Okay, so that's actually a square root. So when you press that button, okay, you will see that you can enter the number that you want inside the square root. Okay, then on top of this square root with a box button, okay, there is a cube root of a box. Okay, so if you press shift followed by the square root box button, you will get the cube root of a number that you can key in. Okay, so I need you to try to make sure that you are able to key in, okay, to get the correct answer. Okay, of course, for this, if you are able to get the values, okay, so if you know this, okay, that's very good mental calculation. 15. Okay, or I want you to try, actually I want everyone to try using your calculator. Okay, the purpose is to know where the sign and the cube root sign, where they are. Okay, so you try that and you should be able to get 15 as well. Okay, now we will go on to question 14, which is practice now 9 on page 14. Okay, so these are the questions in practice now 9. Okay, so they want you to use a calculator to evaluate the following. So they're testing whether you know how to press, you know, a number square, a number cube, you know how to press it as a fraction. So I need to go and try. Okay, so on your calculator, you should be able to see an x square. That means if I were to key in 23 and I press that x square button, I will get 23 square. Okay, then there is an x cube. So if I want 7 cube, I'll press 7 followed by the x cube button to add the cube to the 7 that I have keyed in. Okay, now if you want x to the power of something higher than 2 or 3, you can press the x with a power box. Okay, so if I want 5 to the power of 10, so I press 5 first, then I press the x to the power button, and then a box will appear where I can actually key in the number, okay, for the power. Now after you key in the number for the power and you want to come back to the actual line, you have to press the right button. Okay, there is a up, down, left, right button on the top of the center top of your calculator. So you should press the right button so that it goes down to the normal height. Okay, and not the power of 5. Okay, so try those. Okay, and then you come back and check your answer. Okay, so I want you all to try practice now 9. Okay, it involves some concepts that you should have learned in primary school. So there's one on area and perimeter. Okay, and one on the cubes again that we have seen in the previous practice now example. Okay, but it's slightly different here. So try before you come back to check your answers.